diameter with a 5 core radius. Okay. So has a large diameter core that allows multimode modes of light.
So under
okay. Just give me a minute. Sir,
అటా ఆయన వచ్చాడు మళ్ళీ సరంజామం అంతా అయిపోతుంది
తీసుకెళ్ళిపోయాడు
రాడుగా ఆయన
రాడు తీసుకోవాలి ఆఫ్టర్ ద క్లాస్. But however, because of the high dispersion and attenuation.
So in the previous class, what are the contents we have discussed? Please can you?
So as I said, there will be two. There is the advantage of the multimode fibers. That is, it will have.
What were the previous contents were discussed?
There will be more number of light reflection, and there will be, because of that we can transfer the large data. But as I said, whenever there is a reflection, there is a small amount of energy is lost. Small amount of
yes, tell me what are the previous contents we have discussed?
And because of that, and there will be, because of different number of paths, it is falling.
Principle and construction of optical fiber.
Okay.
Acceptance angle.
Yes.
Multimode fibers for it.
Numerical aperture.
Okay.
So we use for the shorter distances.
So today we have to see the differences between. You have to see the differences between the step index and graded index, and we have to see how the light is transmitted into the fiber. And moreover, we have to go for the topic called optical fiber communications. Just we will revise the differences between the differences between the step index fiber and the graded index fiber. Okay, and then we'll see how the light is transmitted, and then we'll go for. Then we will go for the optical fiber communications, and we'll discuss some numerical, because we have continuous 2 classes, right? So that is the reason. Okay. Yeah. So see here.
This is what we call a local area. So this is about multimode fibers. Now let's summarize the differences between single mode fibers and multimode fibers. So in single mode fibers, there is only one path for ray propagation. Okay, that is light propagation. In multimode fibers, there are large number of paths available for the ray propagation. Right? And a single mode step index fiber has less core diameter, that is 8 to 9 micrometers. Whereas multimode step index fibers have.
So just you see, I'm discussing about types of optical fibers. Based on the variation of refractive index of core, refractive index of core, optical fibers are divided into step index and graded index. So in all optical fibers, the refractive index of cladding and cladding material is uniform. So this is what we show the difference between step index fiber and graded index fiber, right? So based on the mode of propagation, as I told you, all the fibers are divided into 2 groups. One is the single mode, another is the multi-mode. Mode means the number of paths available for light propagation in the fiber, right? If there is only one path, for the ray propagation, it is called single mode fiber. If the number of paths is more than 1, then we call it as multi-mode fiber. Okay. So we shall see what is step index optical fiber. Based on the mode of propagation of light rays, step index fibers are of 2 types. One is a single mode step index fiber, and the multi-mode step index fiber. The light rays propagate here in this form is in the form of zigzag mode. It is what inside the fiber. So this is what the difference. This is what the difference we need to understand between the multimode index and the step index. Just you see the dash, see the figures. So this is the cladding interface and this is the core interface. And in this case, multimode, see how the light rays are getting totally internally reflected here. How they are getting internally reflected in case of multimode step index fiber, because in multimode step index fiber the light ray path, the path of the light ray will be in different directions, right? So for the light to pass in the different directions, we need to go for multimode step index optical fibers, right? So we need also seen what is refractive index profile in step index in single mode step index in single mode step index fiber, right? So the refractive index is uniform towards the fiber. This is all the contents we have discussed. I think you are familiar with this. And here it is core, and this is the diameter of the cladding is around 125 micrometers, and then the core is around 8 to 12 micrometers. So this is what monomode step index fiber, right? So in the refractive index of multimode index fiber, the multimode index fiber, so its core and cladding diameters are much larger to have many paths for light propagation. The core diameter of this fiber varies from 50 to 200 micrometer, and the outer diameter of cladding varies from 100 to 250 micrometer. So light propagation in this fiber is by multiple and total internal reflections. That is, it is a reflective type fiber. It is used in data links which have lower bandwidth requirements. So this is what the diameter it is 2A, and here it is N2, N1, and this is what the situation is. The cladding index, the cladding is having that core diameter around 125 to 400 micrometers, and the core is having 50 to 200 micrometers. So this is what multimode index fiber. So how shall see how the transmission of signal in step index fiber. Generally, the signal is transmitted to the fiber in digital form, as we know, in the form of ones and zeros. In multimode fiber, the pulse width, right? The pulse in multimode fiber, the pulse which travels along the path A, that is straight, right? That is path A straight, will reach first at the other end of the fiber. Next, the pulse that travels along with the path B in the zigzag mode reaches the other end. Right. Hence, the pulsed signal received at the other end is broadened. So this is known as intermodal dispersion. So this imposes limitation on the separation between pulses and reduces the transmission rate and capacity. Right. So in case of graded index optical fiber, to overcome the problem of intermodal dispersion. So there was a problem in a step index fiber. Step index fiber is intermodal dispersion, right? So to overcome this intermodal dispersion, right? The overcome the problem of intermodal dispersion caused due to step index optical fibers, graded index fibers are used. Okay, so the reason behind the existence of graded index optical fiber is intermodal dispersion, right? So to overcome the problem of intermodal dispersion, so intermodal dispersion that was existing in a step index fiber, that was overcome by introducing another type of fiber that is called graded index optical fiber. So to overcome this problem of intermodal dispersion caused due to the step index optical fiber, graded index fibers are used. So this fiber can be single mode or multimode fiber. So here light rays propagate in the form of skew rays or helical rays. Skew rays or helical rays in the sense form in the form of helical shape, right? So they will not cross the fiber axis. So see here, if you can see how the light rays. This is your light rays. This is your light source that is trying to enter at the core with some acceptance angle, right? And it is internally reflected. And this internal reflected is in the form of parabolic path. So the light ray the path that is traveling, the path that is taking place is called parabolic light path. So this is having the refractive index N1, and this is refractive index N2, where N2 is the refractive index of the cladding, N1 is the refractive index of the core. Obviously, N1 should be greater than N2, where N is nothing but the refractive index. So other is a multimode graded index. So this is what we call it as multimode graded index optical fiber. So the significance of introducing graded mode introducing multimode graded index optical fiber is due to the intermodal dispersion, right? So that intermodal dispersion was overcome. In case of multimode graded index optical fiber, right? So refractive index profile in multimode graded index fiber. In this fiber, the refractive index decreases continuously from center radially to the surface of the core, right? So the refractive index is maximum at the center and minimum at the surface of the core. So the diameter of the core varies from 50 to 200 micrometers, and the outer diameter of the cladding varies from 100 to 250 micrometers. Right. So the refractive index profile is circularly symmetric. The refractive index profile is circularly symmetric. So this is what we can see here for the, as we see in the multimode gradient index fiber, the refractive index of the core is approximately 50 to 100 micrometer, and the cladding is approximated to 125 to 140 micrometers. Right. So just see here, as refractive index changes continuously radially in one core, light rays suffer a continuous refraction in core, right? So the propagation of light ray is not due to the internal reflection, but by refraction. So in gradient index fiber, light rays travel at different speeds in different parts of the fiber. Near the surface of the core, refractive index is lower, so rays near the outer surface travel much faster than the rays travel at the center. Because of all these reasons, all the rays arrive approximately at the same time at the receiving end of the fiber. So this is what we explain between this is what we explain in case of gradient index fiber and step index fiber. So we can see some differences between single mode and multi-mode fibers. So in single mode fiber, there is only one path for propagation. I'm telling you again, in multi-mode fiber, large number of paths are available for light ray propagation. So multi-mode step index fibers have larger core diameter around 50 to 200 micrometers, and the difference between the refractive index of core and cladding is large. A single mode step index fiber has less core diameter, less than 10 micrometers, and the difference between the refractive index of core and cladding is very small. In single mode fibers, there is no dispersion. Signal transmission capacity is less, but the single mode fibers are suitable for long distance communication. Signal transmission capacity is more in multimode fibers. They are less suitable for long distance communication. Launching of light into single mode fiber is difficult. Launching of light into multimode fiber is easy. Fabrication cost is very high. Fabrication cost is very less. So this is what we explain the difference between single mode fiber and multimode fiber. And see, we have one more important property of optical fiber is the attenuation, right? So attenuation is the loss of power. Okay. So attenuation, what do you mean by attenuation? Attenuation is the loss of power suffered by the optical signal as it propagates to the power. Right. So attenuation is the loss of power suffered by optical signal as it propagates through the fiber. It is also called the fiber loss. So attenuation attenuation is one of the characteristic properties of loss of optical power. Right? Attenuation is one of the property or one of the characteristic property of the loss, energy loss, right? So that is what attenuation is a loss of power suffered by optical signal as it propagates through the fiber. It is also called fiber loss. Signal attenuation is defined as the ratio of the it is defined how we define this signal attenuation. How do you define this attenuation? It is defined as the ratio of the input optical power pi to the fiber to the output optical power P naught at the other end of the fiber. So that is what we can write it as alpha. Alpha is nothing but the attenuation coefficient, and the attenuation coefficient of the signal per unit length is given as alpha is equals to 10 by L log pi by P naught decibel per kilometer, where pi is the ratio of the optical power pi to the fiber to the optical power received P naught at the other end fiber. So the mechanism which attenuation takes place are the absorption losses, scattering losses, bending losses, and these bending losses, and we have micro bending and waveguide losses. Right. So this is one of the important property of optical fiber, that is nothing but losses. These losses in optical fiber can be studied with a property called attenuation, which is defined as the loss of power suffered by optical signal as it propagates to the fiber. So this is also called the fiber loss. So this signal attenuation is defined as, how we define that parameter again. So it is defined as the ratio of the input optical power pi to the fiber into the fiber to the output optical power received at the other end of the fiber. So pi is the input and p naught is the output. Okay, optical power received at the other end. So input and output, right? So it is defined by a parameter called alpha, which is called the attenuation coefficient. Okay, the attenuation coefficient of the signal per unit length is given as alpha is equals to 10 by L log pi by P naught decibel per kilometer, where L is the length of the fiber. So the mechanism through which attenuation takes place are absorption losses, scattering losses, bending losses, microwave bending, and waveguide losses. So this is what we have, one of the important characteristics, that is the attenuation, right? And now let us see what is optical fiber communication. So what is the block diagram of this optical fiber communication? So optical fiber communication system essentially consists of three parts. Okay. So this is an important question. Please listen carefully, all of you. So optical fibers in communications, right? So optical fiber communication system essentially consists of three parts, namely the transmitter, optical fiber, and receiver. So optical fiber communication system essentially consists of three parts, namely transmitter. We have transmitter, we have optical fiber, and receiver. The transmitter includes modulator, encoder. Okay, the transmitter includes, here we have the transmitter and receiver. So this transmitter includes modulator, encoder, light source, drive circuits, and couplers. Basically, the fiber optic system simply converts an electrical signal into binary data. So binary data by an encoder, right? So the transmitter includes modulator, encoder, light source, drive circuits, and couplers. Basically, the fiber optic system simply convert an electrical signal to binary data by an encoder.
Very small thickness. Okay.
Okay, so here, if you see, please all of you try to draw this block diagram first. Please all of you draw it. After you draw, I will try to explain you some features behind it. Please all of you draw it first. Please draw it.
So we require laser diodes to launch light to single mode fiber, because that is only where the coherence and the directionality comes into the picture. So because we have a very small diameter of the core, and also because of that, and also we have low numerical aperture for the single mode fibers. That's why we require costly laser diodes. That's why it is very costly. It is not second-hand fibers, so very costly. Okay. So there is another kind of stepping edge fiber, that is multimode stepping edge fiber. So where here the diameter of the core will be little bit higher than larger than the single mode stepping edge fiber. Here because as you can see that it is significantly varies. So the value will be 50 to 200 micrometers. As I said, the typical value will be 62.5 micrometers, but you can have from 50 to 200 micrometers. The diameter of the core will be 50 to 200 micrometers.
Rajesh Kunara,
And the value
are you all drawing it?
The diameter of the cladding will be 125 to 400 micrometers. Okay.
Rajesh Kunara Babu,
Fiber is
block diagram of optical fiber communication systems.
Except that its core is of larger diameter. Okay, it is also, so it is also made up of germanium, and core will be made with germanium low silicon, and it is also the client also made with silicon low with phosphorus oxide. Okay. The core diameter, except that the only difference between single mode and multimode stepping fibers are the core has a larger diameter. And the core diameter is of 50 to 100 micrometers, which is very large compared to
Rajesh Kunara Babu,
the external diameter of cladding is about 150 to 50 micrometers, or 125 to 300 micrometers. These are typical numbers, so it's not opposite that you have to remember exact numbers you have in the right, but the order should be this. Okay,
Yes, sir.
125.
right? So optical fiber communication system consists of three parts, namely the transmitter. Okay, so transmitter, optical fiber, and receiver. Okay, so transmitter, optical fiber, and receiver. I think the slide has been disturbed. Okay, so here the transmitter includes. So the transmitter includes. So here we can see here this is transmitter and this is receiver. So we have two important parts. One is the transmitter and other is receiver. So in the transmitter includes the modulator, right? So in the diagram itself we can see it is including the modulator, okay, encoder, okay, encoder, modulator, encoder, light source, drive circuits, and couplers, right? So we have one block here. That block is consisting of modulator, light source, drive circuits, and couplers. Okay, and we have another block called encoder. So there is a bus between the encoder and the other block that is called modulator block, that is called, it is called the binary and electrical signals, right? So basically the fiber optic system simply converts an electrical signal into binary data by an encoder. Okay, so fiber optical system converts an electric signal. So we are giving some electrical signal here, AF audio frequency signal such as voice, okay, in analog form. We are giving it in an analog form, in the form of electrical signal, that will be given to the encoder, right? So that was given to the encoder. So this, what the purpose of encoder is. The purpose of encoder is to convert the electrical signals to binary data, by an encoder, and then it goes to the another block, that is modulator, right? And other, after the light is getting, after the light got encoded, it will reach to the fiber, and we have some repeater. From there we goes to light detector. Okay, from there it goes to light detector, and there is a block called light detector. After that light detector, we have the another decoder. So the encoded signal, after converting from electrical signal to binary signal, after it get converted from electrical signal to binary data. Okay, so it needs to be decoded. So this decoded, the decoded form, that is to be decoded, right, decoded by some decoder. Okay, so this decoding form will be placed in a receiver, right? So the receiver block, we have the light detectors. Okay, so we can see here we have light detectors. Okay, and these light detectors are connected to amplifier decoders, that is what, so electrical signals. Okay, and we get in the audio frequency output form, that is information again in analog form. So this is a process. So this is a process. Okay, again the signal gets entered, and that signal is encoded. Okay, and it is modulated, the signal is modulated, right? And through the modulated signals are sent to the repeaters. Okay, sent to the repeaters, that means they are sent to receiving stations, so the receivers. So through an optical fiber, in the optical fiber we have some in optical receiving part, we have some another blocks called amplifiers, right? Amplifier nothing but to increase the gain of the input signal, right? So to increase the gain of the input signal, we put some amplifiers, right? So we have amplifiers, and we have some light detectors, and from this light detectors, it is given to the light after the light is detected, right, it is amplified. So the light that was detected will get amplified to increase the gain of the signal. So okay, so to increase the gain of the signal, we put some amplifiers, and also that information will be in the form of some digital form, right? So that digital form is again the digital form is again decoded, right? So it is again decoded, and this decoded form is given in the form of audio frequency output, that is information again in analog form. So we are getting the analog forms, how the electrical signal is converting into digital, and the digital to analog. So A to D and D to A. So analog to digital and digital to analog. So by using some cable, by using some optical fiber cable. So in this way, we can explain the block diagram of the optical fiber communication systems, right? So that is what we are trying to put out the information over there. So this binary data comes out as a stream of electrical pulses, and these pulses are converted into pulses of optical power by modulating the light emitted by the light source. This means that laser drive circuits. So we have some laser drive circuits. This means that the laser drive circuit directly modulates the intensity of the laser light with the encoded digital signal. So the digital optical signal is lodged into the optical fiber cable. So the couplers in the transmitters couple the transmitted light signals. So to transmit signals into long electrical regenerators.
This is nothing but what does this point mean? So if you take it one direction, let's say, so here,
right? So see, to transmit the signals
from here to here, so but
to transmit the sites were disturbed, to transmit signals to long electrical generator to signals to long electrical generator, and is sent to distances. Repeaters are used in the transmitter section after certain lengths in the optical.
so that's what we say that fiber.
So in transmitter section, the electrical section, in transmitter section, the electrical signals is again converted back to optical signal and fed to the optical fiber. So an optical repeater consists of a receiver and a transmitter arranged adjacently. The receiver section converts the optical signal into corresponding electrical signals. Further, the electrical signal is amplified by means of an the means of by means of by means of a fiber, right? Finally, at the end of the optical fiber, signal is fed to the receiver. The receiver consists of light detector, which can either be an avalanche photodiode or a positive pin diode, right? So there are different types of diodes where the receivers, where these diodes are placed in a receiving station, right? So in the photodetector signal, the signal is converted into pulses of electric current, which is then fed to the decoder, which converts a sequence of binary data stream into analog signal. So it's nothing but analog to digital, okay, analog to digital, right? So the digital data is sent through an optical fiber to the receiving station. So that is that is the important application, right? That's why optical fibers are used to transmit the data from one point to another point. Right. So some of the applications of optical fibers, some of the applications of optical fibers, if you see, fibers have many uses in remote sensing. So many uses in remote sensing. In some application, the sensor itself is an optical fiber. Optical fibers can be used as a sensor to measure strain, temperature, pressure, and other quantities. Extrinsic fiber optic sensors has the ability to reach places which are otherwise inaccessible. An example is the measurement of temperature used aircraft jet engine, aircraft jet engines. Extrinsic semiconductor can also be used in the same way to measure the internal temperature of electrical transformers. So other applications, power transmission. Okay, so in the optical fibers are used in power transmission. So in what way they are used in power transmission? Optical fiber can be used to transmit power using a photovoltaic cell. Using a photovoltaic cell to convert the light into electricity. Fiber optics are used to net optical fiber can be used to transmit net users, okay, and servers in variety of network sites and increase the speed and accuracy of the data transmitted. They are also used in military as hydrophones for seismic and sonar users. Okay, so sonar users and as writing in aircraft, submarines, and other vehicles, and also for field networking. Broadcast cable companies are using fiber optic cables for writing CATV, HDTV, internet video, and command. So these are all the applications. Okay, these are all applications we need to go for. We need to study in optical fibers. Okay, so these all you can study it, right? So we have some medical applications also. So medical applications also, how medical optical fiber is used in imaging optics. They are used as a light guides in medical and other applications where bright light needs to be shown on a target without a clear line of sight. A coherent bundle of fibers is used along with the lenses for a long, thin imaging device called an endoscope, which is used to view objects through a small hole. Medical endoscopes are used for surgical procedures to view the internal parts of the human body. Industrial endoscopes are used for inspecting anything hard to reach. Such optical fibers look for. Okay, so these are what some of the applications. One is the medical application spectroscopy. Okay, so these are some of the applications you can have. Okay, so these are some of the applications. I'll show you some more applications.
Okay, because there is no refractive index change. So up to that point is constant. So it goes to the core cladding boundary, and there it gets totally general reflection if the angle of incidence is greater than the critical angle. But here what happened is, since there is a change in refractive index throughout the core, and whenever the core refractive index is changing, then it is the light ray gets refracted, and it refracts and refracts. At some point it gets total and internal reflection, and again it travels back, and at this point again it gets through. When it is coming back also it gets refracted. Okay, and it's coming out from this point also it gets refracted. Okay, so this is how the light propagates in a gradient index fiber. So if you can see that these are the possible, so there will be As I said, this is the
So these are certain applications of optical fibers. Okay, now let us go some numericals behind this.
where this the propagation of the light will
Let us do some problems.
okay depending upon the angle of incidence at the A to O. So there will be different paths. The light wave moves in different paths. Okay. So it looks something like this. So you can see that there will be different modes, and it does not the light as you can on
Wait, I'll tell you.
see there. Here,
So
the light ray doesn't need to go all the way to the cladding to get the total internal reflection. Okay. The light ray does not need to propagate up to 4 cladding or 3 for getting the total internal reflection. Wherever it is possible, wherever the angle of incidence is more than the critical angle, there the light gets a total internal reflection and it passes through the X5. Okay. So yeah, basically this is the point. So as the light ray goes from a region of high refractive index to a region of low refractive index, it is bent away from the normal, and the process continues to the condition of total internal reflection. Okay. So they said the darting around may take place even before reaching the core cladding interface. Okay. Now, in the gradient fiber, they making large lines of the axis travels longer path, but they travel in a region of lower refractive index and hence at a higher speed of propagation. Okay. So this point we have to understand this properly. So in gradient fiber, rays making larger angle with the axis travels longer path, but they travel in the region of lower refractive index and hence at a higher speed of propagation. Okay, so let's see here. So if this angle is more, then what happens is it travels a longer path. So as you can see here, there are 2 paths. Okay. This ray is making a lesser angle. This ray is making a lesser angle in the optical axis.
okay.
Or
So let us do some problems. So let us do some problems in this chapter. Okay, any doubt? Any doubt? And doubts on the end?
Whereas this particular ray makes
Any doubt?
angle with the axis.
Any doubt?
But it travels with the higher
Any doubt?
No, sir.
Is it clear? Nothing, just you have to study, that's all. మీరే చదువుకోవాలి అందులో అన్ని. Okay, చదువుకొని పర్ఫెక్ట్నెస్ తెచ్చుకోండి. In case if you feel difficulty, just ask me. Okay, so try to know the differences between gradient index fiber, step index fiber. Okay, and you should understand what is numerical aperture, what is acceptance angle, was it acceptance cone. Okay, so these are some of the questions, and try to understand what is optical fiber communication, block diagram of optical fiber communication. Okay, so let's draw the block diagram and try to explain about the analog to digital conversion, right? Analog to that electrical signals are once focused on encoder, there the signal get encoded in the form of digital pulses, and these digital pulses are then modulated, okay, or then modulated in a receiver, okay, to increase the gain of the signal. So to increase the gain of the signal, the amplifiers are used, and at the receiving end we get the digital signals, right? So for this receiving station we put the devices called pin diode and photodiode and photo detectors, right? And just try to explain the block diagram of the optical fiber communications. Okay, then go for the applications. If you see the applications of fiber optic, these are used in military medical applications and all, whatever that all the nomenclature was studied, just to put it on a paper, right? So that was regarding the optical fiber communications. Okay, and now let us see some of the problems behind this. Okay,
so like that,
yeah,
even at the end of the fiber, these
see, just we'll try to have some problems, try to do some problems from this chapter, lasers and fiber optics. Okay, so the first question is find the just we'll go for the lasers again. Find the relative population of the 2 states. So find the relative population of the 2 states in a ruby laser that produces a light beam of wavelength 6943 angstroms at 300 Kelvin. So this was the question. This is a question. So we have an expression for population inversion, but the expression is not the quality. The quantitative expression is not given. For the but we need to go for the numerical. So is the reason we need to understand what is the expression behind the population inversion. So the expression behind the population inversion is the population ratio is given by n2 by n1 is equals to exponential of minus e2 exponential of n2 by n1 equals to exponential of e2 minus e1 by kt. So we know that e2 minus e1 is equals to h nu. H nu is nothing but c by lambda. So h c by lambda. So we put the expression 6.6 into 10 power minus 34 into 3 into 10 power 8 by 6943 into 10 power minus 10, which we get the value of this one. So n2 by n1 is equals to exponential of this when we get the expression as 8 into 10 power minus 31 is the ratio given. Please note down. Please note down fast. Find the relative population of the two states in ruby laser that produces a light beam of wavelength 6943 angstroms at 300 Kelvin. So the expression is what we given as n2 by n1 is equals to n2 by n1 is equals to exponential of minus e2 minus e1 by kt. So if you note down, just tell me. I'll go to the next problem.
n1 square minus n2 square. But whereas here n1 instead of n1 square, this n1 square depends upon the radius of n1 square is depends upon the radial distance from the axis. So that's why
we copy it.
N square of instead of n1 square. So n square of r minus n2 square. If you substitute this n square of r from the
copy చేసుకున్నారా?
I have given the definition here. So n of r is given by this particular equation. Substitute that we get n1 times 2 delta of r of square root of 1 minus ra by square. So here, why it is instead of alpha, why do we take alpha as 2? That means when you alpha is 2, this basically this particular change will be parabola. And most of the times this alpha value is taken as 2, so that we will have a smooth parabola. Okay. So whatever the values we can calculate the numerical approximation, everything will be easy for us.
Note చేసుకున్నారా?
Here we have taken as
Yes.
okay, whenever alpha is 2, the refractive index profile will be
Note చేసుకున్నారా బాబు?
okay, not looks like parabola, but it's a parabola. The refractive index profile will be parabola.
Yes, sir.
Shall we go to the next problem?
Alpha value as 2. So you can simply send this.
Next problem పెట్టినా? Next problem slide చేయనా? Next problem ki start చేయనా? Shall I go to the next problem?
Yes, sir.
Anyone?
So for a helium neon laser at 1 millimeter, 1 meter and 2 meter distances from the laser, the output beam spot diameters are 4 millimeter and 6 millimeter respectively. Calculate the divergence. So same the formula of divergent, because divergent is one of the characteristic property of the laser. Okay, highly monochromatic, highly divergent, right? The highly monochromatic, high brightness. So these are some of the characteristics of laser. Okay, so one of the characteristics is divergent, right? So the divergent, the expression for divergent is given as theta equals to a2 minus a1 by 2 into d2 minus d1. Okay, so here for helium neon laser at 1 millimeter and 2 millimeter distances from the laser, the output beam spot diameters are observed to be 4 millimeter and 6 millimeter respectively. So what is the divergence? So divergence theta is equals to a2 minus a1 by 2 into d2 minus d1. So a2 is nothing but spot diameters are a2 is 6 millimeters minus 6 millimeters minus 2. Okay, 6 minus 4, right? 6 spot diameters are 6 millimeters minus 4. They are in millimeters. Try to convert them in. Okay, so put it 6 minus 4 into 10 power minus 3 meters. So here it is 2 into d2 minus d1. That distances 1 millimeter, right? 1 millimeter and 2 millimeter. 1 millimeter and 2 meters. So we write d2 as 2 meters and d1 as 1 meter. So we write 6 minus 4 into 10 power minus 3 meters by 2 into 2 minus 1. We get 10 power minus 3 radians. Okay, that is equals to 1 milliradians.
Cladding. Whereas in gradient index fiber,
Okay,
the refractive index is not a constant, but it smoothly varies and decreases as we go away from the axis. Okay, so that is what we call gradient index fiber. And depending upon the number of modes possible, that is number of modes possible, the number of paths available for the light to propagate in the fiber.
is that okay?
Divided into two types. That is, one is single mode and the multi mode. If you have only single path is available for the light to propagate, single mode fiber. And if you have more than one path available for the light to propagate, then we call them as multi-mode fiber. So it combined these two, refractive index and the modes, we have two types of optical fibers are possible. That is step index, single mode fiber, and step index, multi-mode step index fiber. Single mode step index fiber and multi-mode step index fiber, and we have multi-mode gradient index fiber. So these are the three types that we have just discussed now, and how the numerical aperture varies in these two types and how light propagates in each of the fibers that we have just seen. Okay. So are there any doubts? Please go through the. I'll upload these PPTs in the.
Okay. Shall I go to the next problem? Shall I go to the next
Yes, sir.
problem? Yes. Third question. A helium neon laser emits light at a wavelength of 632.8 nanometers and has an output power of 2.3 milliwatts, right? So how many photons are emitted in each minute by this laser when operating? A helium neon laser emits light at a wavelength of 632.8 nanometers and has an output power of 2.3 milliwatts. How many photons are emitted in each minute by this laser when operating? So the wavelength of the laser beam is given as 632.8 nanometers, which is equal to 6328 into 10 power minus 10 meters. So the output power is 2.3 milliwatts. So what is asked to find? How many photons are emitted? Okay, how many photons are emitted in each minute by this laser when operating, right? So initially we have to calculate the frequency. The frequency of the photon emitted is mu is equal to c by lambda. So that is frequency is nothing but this one. The energy of a photon is to be found out. After finding the energy, try the energy emitted by the laser is given. Okay, so the number of photons emitted is output of laser beam, output power of laser beam to energy of each photon emitted by the laser. Okay, so this is a required expression. Okay, what is the required expression? The energy, the number of photons emitted. Okay, the number of photons emitted is equals to output power in laser beam, output power in laser beam to the energy of each photon emitted by the laser beam. Okay, so this is what the expression you have to note it down. So the number of photons emitted, the number of photons emitted is equals to output power in laser beam by energy of each photon emitted by the laser. That is 2.3 into 10 power minus 3 into 60 divided by 3.14 into 10 power minus 19, which is equals to 4.3949 into 10 power 17 photons per minute. Okay, so this is what the required expression is. Okay, copied? Copied? ఏమైతుంది? Hey, please mute yourself. ఎవరది? ఏమవుతుంది అక్కడ? ఎవరది? మ్యూట్ అవ్వండి ఎవరు. ఉన్నారా? నోట్ చేసుకున్నారా ఇది? ఎస్
ఎస్ సార్.
No, sir.
నోట్ చేసుకోండి, నోట్ చేసుకోండి. చేసుకున్నారా? నోట్ చేసుకున్నారా? ఎస్ yes or no?
Yes, sir. Yes, sir.
So next question is, solve the wavelength of emitted radiation from gallium arsenide which has a band gap of 1.44 electron volt. Solve the wavelength of emitted radiation from gallium arsenide laser which has band gap of 1.44 electron volts. The energy gap of a semiconductor is Eg is equals to h nu, where h is the Planck's constant. Eg is equals to hc by nu, that is lambda is equal to hc by Eg. So energy gap is given as 1.44 electron volt. So from that, try to find the value of Eg. Eg is equals to hc by lambda. So that is what the energy gap you have to find out. Okay. Okay na? కాపీ చేసుకోండి బాబు, ప్రాబ్లం. So finished copying. Solve the wavelength of emitted radiation from gallium arsenide, which has a band gap of 1.44 electron volt. Have you copied it? Finished? Finished? Ainda? అయిపోయింది బాబు.
Yes, sir.
So the next question is semiconductor laser diode laser has a wavelength of 1.55 micrometer. Of course, this type of semiconductor diode is not there, but question may be asked. So semiconductor laser is also called one type of laser. Okay, semiconductor laser diode laser has a wavelength of 1.55 micrometer. Find out the energy gap. Okay, the same expression Eg is equals to hc by lambda. So h is nothing but the Planck constant and c is nothing but the velocity of light, and lambda is the wavelength. Okay, wavelength is given as 1.55 micrometers. Just push that expression Eg is equals to hc by lambda and try to find the value. Finished? Ainda copy చేసుకున్నారా? The same expression babu, Eg is equals to hc by lambda, where h is the Planck constant, c is the velocity of light, and lambda is the wavelength of the source. Okay, is it okay? Is it
Yes,
okay or not?
sir.
Huh? Right. So the next question is a step index fiber has a numerical aperture of 0.16 and core refractive index of 1.45. Estimate the acceptance angle of the fiber and refractive index of the cladding. So we have the numerical aperture is 0.16 and refractive index of core is given as 1.45, and we have to find the acceptance angle Imax, acceptance angle, incident angle maximum, and we have to find the refractive index of the cladding, that is N2, right? So the formula is, we know that acceptance angle is equals to sine inverse, that means NA is equals to sine of maximum angle. So therefore I maximum is equals to sine inverse NA. Sine inverse NA is nothing but numerical aperture. Sine inverse of NA. So this is what is given as the numerical aperture is given as 0.16 and the estimated value is 9.206 degrees. Therefore N2 is equals to under root of N1 square minus NA square. 1.45 square minus 0.16 square is equals to 2.1025 minus 0.0256, which is equals to 1.44. So that is what the refractive index of the cladding. Okay. Is that clear? Is that clear? Shall we go to the next problem? Shall we go to the next problem?
Yes, sir.
So the next question is, the refractive index of core and cladding materials of a step index fiber are 1.48 and 1.45. 1.48 and 1.45. So calculate the value of numerical aperture and acceptance angle. So the numerical aperture is given as NA is equals to under root of N1 square minus N2 square, and acceptance angle is the sine of this one. So NA is equals to maximum of acceptance angle is nothing but numerical aperture. So I maximum is equals to sine inverse NA. So this is what the approximated value for incident angle is, that is 70 degrees 15 minutes. Let's copy this also. So these all questions, I think these are all given in question bank. Question bank lo ichara babu ivi unnai check chesara?
Yes, sir.
Question bank lo unnaya ivi? కాపీ చేశారా బాబు? కాపీ చేశారా? కాపీ చేశారా బాబు?
Yes, sir.
So the next question is, an optical fiber has a numerical aperture of 0.2. Okay, as numerical aperture of 0.2 and cladding refractive index is 1.59. Find the acceptance angle for the fiber in water which has refractive index of 1.33. Charge refractive index of 1.33. Yeah, make it fast. The numerical aperture is 0.2. Refractive index of cladding is 1.59. Refractive index of water is 1.33. So we have to find the acceptance angle I max. Okay, so that is equals to, this is the formula. This is the formula, that is Na equals to under root of n1 square minus n2 square, that is 0.2. In water, numerical aperture is sine of I maximum. So that is under root of n1 square minus n2 square by n0. So that is what value is. So I maximum is equals to 8.65 degrees. Okay. So please respond to your roll calls. D1.
Yes, sir.
D2.
Sir. D present, sir.
D4. D4. D5.
Present, sir.
D6.
Present, sir.
D7. D7. D8. D9.
Present, sir.
E0.
Present, sir.
E1.
Present, sir.
E1.
Present, sir.
E2.
Present, sir.
E3. E3. E4.
Present, sir.
E5. E5.
Present, sir.
E6.
Present, sir. Present, sir.
E7.
Present, sir.
E8.
Present, sir.
E9. F0.
Present, sir.
F1.
Yes, sir.
F2. F2. F3.
Present, sir.
F4.
Present, sir.
F5. F5. F6.
Present, sir.
F7.
Present, sir.
F7.
Present, sir.
F8.
Present, sir.
F9.
Yes, sir.
G0.
Present, sir.
G1.
Sir.
G2.
Present, sir. Present, sir.
G3.
Present, sir.
G4.
Present, sir.
G5. G5. G6.
Yes, sir.
G7.
Present, sir.
G8.
Present, sir.
G9.
Present, sir.
H0.
Sir, G5.
H naught. H1,
Present, sir.
H2,
Present, sir.
H3,
Present, sir.
H4, H4, H5, H6,
Present, sir.
H7,
Present, sir.
H8,
Present, sir.
H9,
Present, sir.
J0,
Yes, sir.
J1,
Present, sir.
J2,
Yes, sir.
J3,
Yes, sir.
J4, J4, J5, J6,
Present, sir.
J5 ఉన్నాడు కదా బాబు. J5 లే ఉన్నాడు కదా. J5 లేరా? J6,
Present, sir.
J7,
Present, sir.
J8, J8,
Sir. Present.
J8 వచ్చారా? ఉన్నారా?
Present, sir.
D8 present, sir.
J9,
Yes, sir.
K0,
Sir.
K1,
Present, sir.
K2, K2, K3, K4,
Present, sir.
K5,
Sir, K3 present, sir.
K5,
Present, sir.
K6,
K5 last, sir.
తెలుసు తెలుసు.
Sir, D8
K3 present, sir.
K3 present, okay.
D8, sir.
ఏంటమ్మా?
D8.
D8, okay.
Sir, G1.
Not present.
ఎవరమ్మా?
D2, sir.
Sir. Sir, G1.
Even okay బాబు.
H not present, sir.
ఆ?
H not.
Sir, K2 present, sir.
K2, okay.
Sir, F2, sir.
G5, okay.
Sir, F2, sir.
F2, okay.
H not, sir.
H0, okay అమ్మా.
Sir, G0.
G0, okay. అంతే. So the absent are D4, D7, E3, E9, F5, H4, H5, J5, J4. J4, J5. Okay. Next question. Calculate the fractional refractive index change for an optical fiber if the refractive index of the core and cladding are 1.563 and 1.498. So what is the expression? Delta equals to N1 difference N2 by N1, where N1 difference N2 is the difference between the refractive index of core and cladding to the ratio of refractive index of the core. That is delta equals to N1 difference N2 by N1. So this is what the fractional refractive index change is expression. So this is what the answer is, 0.0416. So N1 is given as 1.563 and N2 is given as 1.498 divided by 1.563, which is equal to 0.0416. Okay. Okay. Is that okay? Is that okay? Shall I go to the
Yes,
next
sir.
problem? Shall I go to the next problem?
Yes, sir.
Right. when the mean optical power launched into an 8 kilometer length of fiber is 120 micrometer. This means optical power of the fiber output is 3 microwatt. Find the overall signal attenuation and signal attenuation
Hello,
per kilometer.
sir. So J for prime, sir.
Eh?
Sir,
J4.
ఇది నెట్వర్క్ ఇష్యూస్ సిస్టమ్ మారినా సార్ మొబైల్ మార్చిన
Okay, J4, okay.
లాగౌట్ J for.
Okay, okay. So please note down this problem. When the mean optical power launched into an 8 kilometer length of fiber is 120 microwatt, the mean optical power at the fiber output is 3 microwatt. Find the overall signal attenuation and signal attenuation per kilometer. First, you have to find the overall signal attenuation, and then we have to find the signal attenuation per kilometer. So overall signal attenuation or loss in decibels through the fiber is given by alpha dB, signal attenuation coefficient per unit length. Alpha dB L equals to 10 log base 10 pi by p naught, which is equals to 10 log base 10. So this value, that is 16.0 decibels. So the signal attenuation per kilometer of the fiber is given by alpha dB is equals to 16.0 decibels. So as L equals to 8 kilometers, so alpha dB is equals to 16.0 by 8. So therefore the attenuation coefficient alpha dB in decibels is given as 2 decibels per kilometer. So this is what the question is. So when the mean optical power launched into an 8 kilometer length of fiber is 120 micrometer, the mean optical power at the fiber output is 3 microwatt. Find the signal attenuation and signal attenuation per kilometer. So this is the answer. Please copy it down. ఎవరది మ్యూట్ అవ్వండి.
मेरी गल एक नई चालू सीधा
ఎవరా బాబు ఇది? So these are the problems. Okay, so these are the problems, numericals. Please try to follow all the numericals because maximum are present in the question bank. Maximum questions are there in the question bank. Just you go through the question bank, and if there are missing, if the problems somewhat are missing, just you please let me know so that we can discuss some more. Okay, is that okay? Okay. ఓకే, ఎనీ డౌట్స్? ఒకసారి చూసుకున్నారా క్వశ్చన్ బ్యాంక్? H4 ఉన్నారా బాబు? H4
ఎస్ సార్, ఉన్నాను సార్.
అటెండెన్స్ చెప్పలేదు కదా బాబు?
ఉన్నాను సార్. నెట్వర్క్ ఇష్యూ.
నెట్వర్క్ ప్రాబ్లమా?
సార్.
H5 లేడు. H7 J5 కూడా ఉన్నారా? 21951 J5 కూడా ఉన్నారా? J5 ఇక్కడ ప్రెసెంట్ కనబడుతుంది, మరి వాయిస్ ఏం లేదు. వీడియో అయితే బంద్ చేసింది. ఒకసారి వీడియో ఆన్ చేయండి. ఎవరది? J5 బాబు, మీ వాయిస్ లేకపోయినా పర్లేదు, ఒకసారి వీడియో అయితే ఆన్ చేయండి. J5 ఉన్నారో లేదు, ఎందుకంటే J5 ఇక్కడ ప్రెసెంట్ చూపెడుతోంది. బాబు ఒకసారి ఇక్కడ J5 ఆన్ చేయండి బాబు. J5 ఆప్షన్ పెడుతున్నాను. J5 అయితే కనపడుతున్నారు, బట్ వీడియో ఆన్ చేయండి బాబు ఒకసారి. వాయిస్ అయితే లేదు. J5 ఈ బాలకృష్ణ ఎవరండి? పి బాలకృష్ణ
సార్.
మీదేనా? నెంబర్ ఎంత బాబు?
సార్ సిఎంఎస్ నాకు ఇంకా ఐడి కార్డ్ తీసుకోలేదు సార్.
ఇంకా ఐడి కార్డ్ సెమిస్టర్ అయిపోవచ్చింది కదరా బాబు, ఇంకా ఐడి కార్డ్ తీసుకోపోవడం ఏందిరా నాయన నువ్వు?
సార్ ఫీజు కట్టలేదు సార్, సిఎంఎస్ లాగింది 20,000 జేఎన్టీ ఫీ. ఇంకా
కట్టపోతే ఎట్టారా బాబు? సరే చూసుకో.
ఓకే సార్. సరే ఇవ్వండి సార్ ఏమన్నా ఇంపార్టెంట్ క్వశ్చన్స్.
ఏం క్వశ్చన్స్ ఇంపార్టెంట్ కావాలా నీకు?
సార్ అదేం మొత్తం అన్ని చెప్తున్నారు సార్, కొన్ని ఏంటి సార్ ఇంపార్టెంట్ క్వశ్చన్స్?
అన్ని చెప్పాలి కదరా, క్వశ్చన్స్ ఇంపార్టెంట్ ఏ ఉన్నారా నాయన? అన్ని క్వశ్చన్స్ చెప్పాలి, అన్ని చెప్పాలి. క్వశ్చన్ బ్యాంక్ లో ఉన్నాయి అవే ఇంపార్టెంట్ క్వశ్చన్స్.
సార్ పోనీ ఒక మెటీరియల్ అన్ని ఇవ్వండి సార్, ఆ మెటీరియల్ బట్టి చదువుకుంటాము.
మెటీరియల్ సిఎంఎస్ లో పెడుతున్నాం కదరా బాబు రోజు.
సార్ ఇక ఆ ఫోన్ ఓపెన్ చేసి నెట్వర్క్ ఇష్యూ ఉంటుంది కదా సార్, కొంచెం మెటీరియల్స్ ఏమైనా బుక్స్ ఇవ్వండి సార్, కాలేజ్ లో ఇంటర్లో ఇచ్చినట్లు.
అరే నువ్వు ఫీజే కట్టలేదు, నువ్వు ఐడి కార్డ్ తీసుకోలేదు, నీకు బుక్ ఎట్లా ఇస్తారా కాలేజీలో?
సార్ ఫీజు కట్టిన వాళ్ళకన్నా ఇవ్వాలి కదా సార్. మరి
మీరు వచ్చి తీసుకోవాలి, మీరు ఐడి కార్డ్ తీసుకొని ఇష్యూ చేసుకోవాలి. బుక్స్ తీసుకున్న వాళ్ళు లేరా బాబు?
లేరు సార్, ఎవరు అడగండి సార్, మా క్లాస్ లో ఎవరు తీసుకోలేదు సార్.
తీసుకోలేదు అని చెప్పు, వాళ్ళు ఇస్తున్నారు, మీరు తీసుకోవట్లేదు.
ఎక్కడ సార్ 20,000 కట్టాలంటే మళ్ళీ 2,000 బుక్స్ కట్టాలంట సార్.
మరి కట్టపోతే ఎట్లా? మరి కట్టాలి కదరా, లేకపోతే నువ్వు కాలేజీకి వచ్చి నాకు మెటీరియల్ అడుగు నేను ఇస్తా, అట్లాగే నేను ఎట్లా అని చెప్పి నీకు ఇప్పుడు.
సార్ నేను వస్తా సార్, ఈరోజు కాలేజ్కి వస్తా సార్, మెటీరియల్ కోసం అన్న వస్తా సార్. ఏం అర్థమైతలేదు సార్, క్లాస్ వర్క్ ఇన్కంప్లీట్ ఉంది సార్ నాది.
మరి తప్పు నీది కదా, క్లాస్ వర్క్ తప్పు లేనప్పుడు, ఇన్కంప్లీట్ ఉన్నప్పుడు తప్పు నీది, నువ్వు కంప్లీట్ చేసుకోవాలి.
ఎవరిదాన్ని క్లాస్ వర్క్ అడుగుదాం, నోట్స్ పెట్టండి రా అంటే ఎవరు పెడతలేదు సార్ ఫొటోస్. మా ఇన్కంప్లీట్ ఉంది అంటారు.
ఎవడు వాడు చదువుకుంటున్నాడు, నువ్వు వచ్చి నోట్స్ తీసుకొని పోవాలి.
ఓకే సార్.
అర్థమైందా?
అర్థమైంది సార్.
లేకపోతే వచ్చి వాట్సాప్ తీసుకొని పో, అది పోయి ప్రింట్అవుట్ తీసుకో బయటికి పోయి.
ఓకే సార్.
నువ్వు రాకపోతే ఎట్లా తెలుస్తుంది రా? ఇప్పుడు నువ్వు చెప్పినావు నాకు తెలిసింది, ఇప్పుడు నువ్వు వస్తే నేను ఇస్తాను, లేకపోతే మిగతా వాళ్ళ సంగతి నాకేం తెలుస్తుంది చెప్పు? ఎవరి సంగతి ఎట్లా?
అంతే సార్.
అంతే కదా. బుక్స్ ఇవ్వట్లేదు అంటున్నావు, కాలేజీలో ఎందుకు ఇయ్యారు? బుక్స్ ఇస్తారు కాలేజీ వాళ్ళు. మీరు సరిగ్గా వచ్చి అప్రోచ్ అయితే అన్ని ప్రాసెస్ ఫార్మాలిటీస్ కంప్లీట్ చేసుకుంటే ఇస్తారు. నువ్వు ఏం చేయకుండా బుక్లు ఇవ్వట్లేదు, ఏమి ఇవ్వట్లేదు అంటే తప్పు కదా. అట్లా బదనాం చేయదు కదా కాలేజీని.
అంతే సార్.
మరే నువ్వు తీసుకుంటలేవు బుక్స్ వచ్చి. బుక్స్ ఎందుకు ఇవ్వట్లేదు? అందరికి ఇస్తున్నారు.
సార్ ఒకసారి ఎవరినన్ను అడగండి సార్, ఎవరినన్ను అడగండి సార్ బుక్స్ తీసుకున్నారేమో అని.
ఎవరిని అడగడం ఎందుకురా బాబు? ఎవరికి గంటలు తీసుకుంటారు, ఎవరికి కావాలన్నా వాళ్ళు తీసుకుంటారు. ఇప్పుడు నీకు కావాలన్నా నువ్వు కాలేజీకి వస్తా అంటున్నావు, తీసుకుంటున్నావు. నీకు వద్దపోతే నువ్వు వస్తావా చెప్పు? నీకు మరి గదే కదా, సింపుల్.
ఓకే సార్.
ఇంకెవరన్నా మా ఇక నోట్స్ చూసుకోండి. మొన్నటిదాకా నోట్స్ అయితే క్లాస్ లో ఉన్నది రాసుకున్నారా? కొంచెం ప్రిపేర్ అవ్వండి గట్టిగా. సో మండే నాడు నెక్స్ట్ చాప్టర్ స్టార్ట్ చేద్దాం. ఆప్టిక్స్ అండ్ ఇంటర్ఫిరెన్స్ డైఫ్రాక్షన్ ఉన్నాయి కదా, నెక్స్ట్ కంటెంట్ స్టార్ట్ చేస్తే అయిపోతుంది. ఈ ప్రాబ్లమ్స్ అన్ని ప్రిపేర్ కాండి. అర్థమైందా? లేజర్స్ లో ఏం లేదని చెప్పినా కదా, రూబీ లేజర్, హీలియం లేజర్ చదువుకోండి. ఆ 2 లేజర్స్ చదువుకుంటే మెటాస్టేబుల్ స్టేట్ పాపులేషన్ ఇన్వర్షన్ అంతా కవర్ అవుతుంది. నెక్స్ట్ ఆప్టికల్ ఫైబర్స్ లో వాట్ ఈస్ న్యూమరికల్ అపర్చర్, వాట్ ఈస్ యాక్సెప్టెన్స్ యాంగిల్, వాట్ ఈస్ యాక్సెప్టెన్స్ కోన్, వాట్ ఆర్ ద లాసెస్ ఇన్ ఫైబర్, అండ్ రా ద బ్లాక్ డయాగ్రామ్ ఆఫ్ ఆప్టికల్ ఫైబర్ కమ్యూనికేషన్. 3 క్వశ్చన్లు ఉంటాయి దానిలో. అయిపోయా. ఇంకా ఇంపార్టెంట్ ఏమున్నది రా బాబు నీకు? అదే క్వశ్చన్ బ్యాంక్ లో ఉండే క్వశ్చన్సే కదా అందరు చదువుకునేవి.
క్వశ్చన్ బ్యాంక్ లో ఉన్న క్వశ్చన్స్ సార్, కానీ దాని ఆన్సర్స్ ఉండాలి కదా సార్ మా కాడ.
అరే ఆన్సర్స్ చెప్తున్నా కదా, నువ్వు రోజు స్లైడ్ చెప్తున్నా కదా, స్లైడ్ నోట్ చేసుకో. ఇమీడియట్ గా పెడుతున్నా కదా స్లైడ్ పెట్టినప్పుడు వెంబడి ఇమీడియట్ అన్నదన్నా నోట్ చేసుకుని పోవాలి. నువ్వు నోట్ చేసుకోలేదో నాకేం తెలుస్తుంది? ఆఖరికి అడుగుతూనే ఉన్నా, ఓకేనా, పక్కకు పోనా అని అడుగుతూనే ఉన్నా. ఓకే అంటే నేను పక్కకు పోతున్నా, నువ్వు నోట్ చేసుకోవాలి. అదే చెప్పు బాబు.
సార్ లాంగ్ ఆన్సర్స్ సార్.
ఏంటి బాబు
లాంగ్ ఆన్సర్స్ అన్న చెప్పండి సార్.
అరే లాంగ్ ఆన్సర్స్ బాబా ఇవన్నీ. హీలియం నియాన్ లేజర్ లాంగ్ ఆన్సరే, రూబీ లేజర్ లాంగ్ ఆన్సరే, అదే ఆప్టికల్ ఫైబర్ కమ్యూనికేషన్ అది లాంగ్ ఆన్సరే. అర్థమైందా? ఇక 1 మార్క్ క్వశ్చన్స్ అంటవా? వాట్ ఈస్ మెటాస్టేబుల్ స్టేట్, వాట్ ఈస్ పాపులేషన్ ఇన్వర్షన్, వాట్ ఈస్ న్యూమరికల్ అపర్చర్, వాట్ ఈస్ యాక్సెప్టెన్స్ యాంగిల్.
సార్ ఇప్పుడు మీరు చెప్పేది దాని ఆన్సర్ ఒక్క ముక్క తెలుసా నన్ను అడగండి సార్. మీరు చెప్పేదానికి ఒక ఆన్సర్ తెలియదు సార్ నాకు. మీరు ఇప్పుడు క్వశ్చన్ అడుగుతున్నా,
నేనేం చేయను. నువ్వు వినకుండా నన్ను అడగాలి కదా. ఇప్పుడు నువ్వు మాట్లాడుతున్నావు, ఇట్లా మాట్లాడచ్చు కదా. సార్ నాకు అర్థమవుతలేదు సార్, వినపడతలేదు సార్ అంటే మళ్ళీ చెప్పన్నా చెప్పు? నువ్వు ఇంత ఓపెన్ గా మాట్లాడితే నేను ఎందుకు చెప్పాను నీకు?
అంతే సార్.
నేను అందరికి మొత్తుకుంటూనే ఉన్నా, ఓకేనా అంటే ఎవడు మాట్లాడు, ఎవడు రెస్పాండ్. నేను క్లాస్లో చెప్పిందే జరుగుతుంది. ఆన్లైన్ అయితే ఇక ఆన్లైన్లో పరిస్థితికి ఇట్లా అంతే ఉంటుంది. అందరు ఆన్లోనే ఉన్నారు, అందరు ప్రెసెంట్ ఉన్నారు, ఎవడు రెస్పాండ్ అయితే లేదు. ఏం లేదురా బాబు, చాలా ఈజీ టాపిక్స్ రా బాబాయ్. అర్థమైందా?
అవును సార్.
ఆ క్వశ్చన్ బ్యాంక్ లో ఉన్న క్వశ్చన్సే అవి ఎత్తుకరా, నీకు ఫ్రీ అయితే. వచ్చినప్పుడు నోట్స్ ఇస్తా, రాసుకో, చదువుకో, పాస్ అవ్వు. అర్థమైందా బిడ్డ?
అర్థమైంది సార్.
వస్తే మరి నువ్వు ఇస్తే నాకేం తెలుస్తారా బాబు? మీరు ఏం చేస్తున్నారు ఆడ, ఏం చదువుతున్నారు, ఏం చదువుకుంటున్నారు, మనకేం తెలుస్తుందా? ఓకేనా
సార్?
ఇంకెవరు ఉన్నారా అమ్మా ఇట్లాంటి వాళ్ళు ఎవరైనా? నేను మొన్న ఆఖరికి ఏదో క్వశ్చన్ బ్యాంక్ కూడా పెట్టినా మీ క్లాస్ సిఆర్ కి, మరి మీకు అందరు ఫార్వర్డ్ చేసినా అన్నాడు. మరి నోట్స్ కూడా పెట్టానా అబ్బాయికి? మరి
పెట్టండి సార్.
వాట్సాప్ గ్రూప్ లో మీరు నోట్స్ పెట్టండి సార్ మాకు.
అది 100 పేజీల నోట్స్ రా బాబు, నా ఫోన్ నిండుతుంది అది.
మళ్ళీ
నేను
డిలీట్
మెయిల్
చేయండి.
చేస్తా, నేను మెయిల్ చేస్తాను నోట్స్.
సిఆర్ చేయండి సార్, మెయిల్ చేయండి మా సిఆర్ కి. మా సిఆర్ మాకు వాట్సాప్ గ్రూప్ లో సెండ్ చేస్తాడు.
ఓకే డన్. మరి నాకు ఆ విషయం చెప్పాలి కదరా బాబు, మీరు చెప్పకపోతే నాకేం తెలుస్తుంది? నేను స్లైడ్ పెడితే మీరు రాసుకుంటారేమో అనుకుంటున్నా. క్వశ్చన్స్ అండ్ ప్రాబ్లమ్స్ అని ఎక్కించుకున్నారా, అవన్నీ ఎక్కించుకోలేదా?
సార్ క్వశ్చన్స్ ఉన్నాయి సార్, క్వశ్చన్ బ్యాంక్ పీడిఎఫ్ ఉన్నాయి సార్.
కాదురా బాబు, కాదురా నాయనా, ఇప్పుడు ప్రాబ్లమ్స్ ఎక్కించుకున్నారా లేదా అని అడుగుతున్నా.
సార్ నేను ఉండేది నిజామాబాద్ లో సార్, మా ఊర్లో సిగ్నల్ ఉండదు సార్ సరిగా. ఇప్పుడు చెట్టు కిందకు వస్తున్నా సార్, ఇప్పుడు వచ్చింది సార్ సిగ్నల్ నాకు.
అరే మరి ఎట్లయితే ఎట్లరా బాబు, మన నువ్వు ఫోన్ కాంటాక్ట్ అయినా అవ్వాలి కదా.
మా సిఆర్ కి పెట్టండి సార్, అది మీ పర్సనల్ నోట్స్ మెయిల్ కి పెట్టండి సార్ మా సిఆర్ కి. మా సిఆర్ మా క్లాస్ లో గ్రూప్ లో పెడతాడు, వాట్సాప్ గ్రూప్ లో.
వాళ్ళు ఫార్వర్డ్ చేస్తా మీ సిఆర్ కి. అబ్బాయి మెయిల్ ఏదో ఉన్నది కదా, ఆ అబ్బాయి మెయిల్ కి నేను నోట్స్ అంతా పెడతా. 100 పేజీల నోట్స్ ఉన్నాయి
సార్ డొమైన్ మెయిల్ కి.
డొమైన్ మెయిల్ కి పెడతారా బాబు, పర్సనల్ మెయిల్ కి పెట్టండి రా. పర్సనల్ మెయిల్ కి ఎట్లా పెడతా? డొమైన్ మెయిల్ కే పెడతా. వాడు ఏమైతే మెయిల్ ఇచ్చిందో మీ సిఆర్, ఆ మెయిల్ కే పెడతా. సరేనా?
థ్యాంక్ యూ సార్.
పెడతా, చదువుకోండి. ఇక మీరు రాగానే ఎగ్జామ్స్ దిగుతాయి. సిఐఈ 1
ఆఫ్లైన్ అయినా సార్ పక్కా?
ఏమరా బాబు, ఆఫ్లైన్ ఆన్లైన్ ఏదవుతుందో మాకు తెలియదు. ఆఫ్లైన్ అయితే ఉండదు, సెకండ్ వీక్ ఉంటుందేమో అనుకుంటున్నా. ఫస్ట్ వీక్ అయితే ఉండదులే కానీ సెకండ్ వీక్ ఉంటుంది.
ఓకే సార్.
మీరు దిగంగానే ఇక పరీక్షలే ఉంటాయి వరుసగా. ఫస్ట్ హాఫ్ పరీక్షలు, మళ్ళా సెకండ్ హాఫ్ పరీక్షలు, మొత్తం పరీక్షలే. ఇక జాగ్రత్త చదువుకోండి.
ఓకే సార్.
ఓకేనా? ఇంకెవరు ఉన్నారా అమ్మా? ఇంకేమైనా ఉన్నాయి? నోట్స్ ఒకటి పెట్టుకుంటే సరిపోతుంది. ఫస్ట్ యూనిట్ నోట్స్ ఉన్నదా క్వాంటమ్ మెకానిక్స్?
అది ఉంది సార్ నాకు ఆడ.
మరి నెక్స్ట్ యూనిట్ ఎలక్ట్రిక్ సాలిడ్స్ అండ్ సెమీ కండక్టర్స్
అది లేదు సార్, సీరియస్ గా చెప్తున్నా సార్, అది లేదు సార్. అది అసలు ఆ లెసన్ నాకు తలకాయ నొప్పి, అర్థం కాలేదని చెప్పి వదిలేసిన సార్ నేను ఆ లెసన్ ని.
అర్థం కాకపోతే వదిలేస్తావారా? ఏదైనా సినిమా అర్థం కాలేదంటే వదిలేసినావా? చూస్తావు ఎవరు 2-3 సార్లు?
చూస్తా సార్.
అర్థం కాకుండా వదిలేస్తే ఎట్లా? మరి మార్క్స్ లూజ్ అవుతావు కదా నువ్వే.
మాడ్యూల్ 1 లో మంచిగా అర్థమైంది సార్, డీ బ్రోగ్లీస్ మెథడ్ అంతా బాగా అర్థమైంది సార్. దాంట్లో అయితే
నువ్వు శ్రద్ధ విన్నావు అప్పుడు వచ్చిన కొత్తలో కాబట్టి బాగా విన్నావు. ఇక తర్వాత కొద్దిగా పాత పడ్డావు కదా, ఇక ఇంట్రెస్ట్ తగ్గుతుంది. అందుకే ఇక అర్థం కాలేదు సార్, మధ్యలో పోయినావు. అప్పుడే పాటలు గీటలు అన్నారు, ఎగిరిరు. అప్పుడు మధ్యలో క్లాసులు అందరూ ఎగ్గొట్టిరు. అంతే కదా?
అవును సార్.
మళ్ళీ తర్వాత వచ్చేది
సార్ ఫ్రెషర్స్ కానీ డాన్స్ కానీ ఎల్లుండే, ఇంకా మా మధ్యలో ఎగిరిపోయింది.
అర్థమవుతుంది. ఇక నువ్వు చెప్పుడే నాకు అర్థమవుతుంది. ఇక పోయిన డాన్స్ పోయినావు, డాన్స్ చేసినావు, బాగానే ఉన్నది. ఆ రోజు అయిపోయింది. మళ్ళీ తర్వాత మళ్ళీ ఏమైంది, ఏంది కథ, ఎంతవరకు ఉన్నది, ఏంది నోట్స్ ఉన్నదా లేదా? నువ్వు ఒకసారైనా వాకప్ చేసినావా కాలేజీలో సార్లని కానీ ఎవరినైనా?
లేదు సార్, చేయలేదు. భయం వేసింది సార్. అప్పుడు
భయం ఎందుకు రా బాబు? మేము
ఆల్రెడీ ఒకసారి వేసుకున్నారు. క్యాల్కులేటర్ మాట కొనుక్కోలేదు, 700 పెట్టి ఫ్రెషర్స్కి వెళ్ళడానికి వేసుకున్నా అని చెప్పి గమ్ముకున్నా సార్.
ఎవరో ఒక్కళ్ళు అట్లుంటారు, అందరు అట్లుంటారా బాబు? అందరు అట్లుంటారా? నువ్వు రా